Hey guys, welcome to 3.2 Mean Value Theorem and Rolle's Theorem. In this video, we're going to be talking about these two special theorems in calculus. So let me go ahead and begin by drawing a graph. And I'm going to draw a graph that's closed on the interval from A to B. And I'm going to draw it so that it's continuous and differentiable, which means smooth. Let me draw that a little bit better. That's perfect. Okay, so let me go ahead and connect these two endpoints. And when I connect the endpoints, I form what is called a secant line. A secant line, you guys learned in pre-calculus, represents the average rate of change, or represents the average of these 2 points, which is a slope. And if you recall, your slope is y2 minus y1 over x2 minus x1. But let me go ahead and find slope in a different way. Well, it's actually the same way, but more formally. If that point is A, then this is f of A. If that point is B, this is f of B. So the slope is defined as the change of the y and over the change of the x. So slope, the average rate of change, is equal to f of b minus f of a all over b minus a. That is just the slope. In calculus, we like to find the instantaneous rate of change. So here's my question. Is there an instance, 1, 2, 3, or 4? Is there at least one instance at which the slope of the secant line could be equal to the slope of the tangent line, which is a derivative? And the answer to that question is yes, there is at least one instance. In this case, we have maybe a point here, C1, at which the slope, well, I drew it kind of off, but at which the slope is equal to the slope of this line here. Could there be another one? Sure. Over here. We'll call this C2. And even one more up here. What do all these three slopes have in common? I'm sorry, all these four slopes. They're all the same slope. So the question that I had asked, could the average rate of change be equal to the instantaneous rate of change if you're on a closed interval and your function's differentiable? And the answer to that is yes, and we call that the mean value theorem. If f is a function that is continuous on a to b, here's the first condition, and differentiable on a to b, not including a to b, then there is at least one number c in a to b such that the average rate of change, and let me write it like this, the instantaneous rate of change is equal to the average rate of change. Another way to say this is the slope of tangent is equal to the slope of secant. But the most formal way to write this, and this is in every textbook, every calculus textbook, is the derivative at c is equal to the average rate of change of a to b, of the function from a to b. So this is the part that you really want to know and memorize, or at least understand. Let me go ahead and give you guys a representation of this. So if my graph did not make any sense, hopefully this representation will. Here I have a smooth and continuous curve on a closed interval from a to b. This P represents a point of the on the graph, and this small black line segment represents the derivative, the slope of the tangent line. If I connect the endpoints A to B, I have what is called the secant line, or the average slope, the average rate of change, my secant. Now, how many instances do you guys think the derivative is equal to the average? In other words, how many instances is the tangent line of this curve equal to the secant? Let me go ahead and just start sliding this derivative around. As you can see, the derivative is always changing, positive to negative, positive to negative, and then it goes from negative to positive. Now the answer to my question is 1 and 2. So in this function there are two instances at which the derivative is equal to the average. Hopefully this helped. Now let me go ahead and talk about the last theorem. So before we talk about that theorem, notice that A was at a different height than B. What if A and B shared the same height? I'm over here now. If f of A is equal to f of B, this special case of the mean value theorem is called Rolle's theorem. So let me go ahead and draw another graph. And let me draw it so that it's smooth and continuous, and A and B share the same height. Let me go ahead and draw the curve. Let's say I want to do something more simple. Loop up, loop down, and back up. Okay. Now, here is my differentiable and continuous curve f. If I take the average of A to B, I have a straight line. What is the slope of this straight line? 0. So my average rate of change is 0. Now, how many times does my derivative have 0 in this graph? Once and twice. They always occur where there is a minimum and a maximum value. Slope of 0, slope of 0. So here is Rolle's theorem. Rolle's theorem says if the function is continuous on A to B and differentiable on A to B, and the third condition says if f of A and f of B are the same height, then there exists at least one c in A to B such that the derivative at some c is equal to 0. And that is the Rolle's theorem. Okay, so on the next video I'll have some problems worked out for you guys, and hopefully you guys enjoyed the animation. Thank you so much.